Exercise 59, page 115, question number 9. In this particular question, we've got an exponential growth to a limit curve. The 1 minus e to the minus t over rc is an exponential growth to a limit. So if I were to plot the curve, it would look like this. It would start at 0 and approach some sort of limiting value, which turns out to be this figure here, 12.5. So that's what the shape of the curve looks like, and you can use autograph to confirm that a bit later on. But in this particular question, you're asked to, for part of the question, find part B, find the time for the current to reach 10 amperes. So I want to focus on that particular part, because we need to rearrange the formula to get that. So I'm going to take this function I equals 12.5, 1 minus e to the minus t over rc, and rearrange it for little t, and then put the value for rc in. Note that R and C are given. R is 30 kiloohms, which is 30 times 10 to the 3 ohms. C is 20 microfarads, which is 20 times 10 to the minus 6 farads. Multiplying them together, we get Rc. Again, we could do that without a calculator, because 30 times 20 gives us 600, and then adding the powers, 3 plus minus 6 is minus 3, so we get 600 times 10 to the minus 3, and that is actually equal to 0.6. So the answer is 0.6 ohm farads for Rc. So now we can plug that value in here for Rc. We could do that at the start, but I'm going to leave it as Rc, because then you've got the general formula. So let's take this function then. I equals, in this particular case, 12.5, 1 minus e to the minus t over rc. There's two ways we can proceed here, so I'm going to go both ways and show that they actually give the same answer. So the first way to do this will be to multiply out the brackets. So I equals 12.5 times 1 is 12.5 minus 12.5 e to the minus t over rc. Now, this term involving what we want, the time, this whole term is negative. So add that to both sides of the equation to get it to be positive. So little I plus 12.5 e to the minus t over rc equals 12.5. Now take I over the other side. We get 12.5 e to the minus t over rc equals 12.5 minus I. Now divide both sides by 12.5 and I get e to the minus t over rc equals 12.5 minus I over 12.5. Using the fact that the negative power means it's the inverse, we get 1 over e to the t over rc equals 12.5 minus I over 12.5, which means we can now invert these two fractions. So that over that can be inverted, and so can that. So we actually get that e to the t over rc equals 12.5 over 12.5 minus I. With time, you can just jump straight from there to there. Do that inversion in one hit. Now, we'll take the log of both sides. So t over rc equals the natural log of 12.5 over 12.5 minus I. And Now multiplying both sides by RC, we get T equals RC log 12.5 over 12.5 minus I. So that's one way of going about doing this. What about the other way? Well, let's just put a line down here so that I don't mix up the two methods. Okay, so going the other way, starting at this point, instead of multiplying out the brackets, we might decide to divide both sides by 12.5. So I over 12.5, let's have some more room, equals 1 minus e to the minus t over rc. Now again, because this term involving the time is negative, add that to both sides. So we get I plus I over 12.5 plus e to the minus t over rc equals 1. Now subtract the I over 12.5 and we get e to the minus t over rc equals 1 minus e, 1 minus I over 12.5. However, we can't invert at this point because we've got two fractions this side. We cannot just invert the two sides. 1 over 2, 1 over 4 plus 1 over 4 equals 1 over 2, but inverting 4 over 1 plus 4 over 1 does not equal 2. So we can't invert these two sides because we've got two fractions on this side. So what I need to do is to make the denominator the same on this right hand side. So there's a bit of an algebraic trick at this point. We need to say that e to the minus t over rc equals 1 is the same as 12.5 over 12.5 minus I over 12.5. So I call 1 12.5 over 12.5 so that the denominators are the same. They're both 12.5. Now I can combine these two fractions and we get e to the minus t over rc equals 12.5 minus I over 12.5. And then we find we're at the same as we were here. So now I can invert the fractions and I'll get the same answer as before.